6, part 2. Just turned it on, so we're going to record for all of our IB people that are gone. So that Mrs. Morgan can say she was nice one day this year, okay? One day. This is the day. This is my nice day. Okay, 6, part 2 for vectors. We're going to finish our work on vectors. We're going to talk word problems on Monday. But today we're going to talk about how to find a unit vector that's going in the same direction as a given vector. Okay, we're going to talk about what a unit vector is. We're going to talk about how to find a direction angle. I'm going to give you a formula, but I'm going to show you how you can find it if you forget the formula. Do you know right triangle trig? Anybody know anything about SOHCAHTOA? If you know SOHCAHTOA, you can do a direction angle. It's not hard. And then we're going to have to write a vector in terms of magnitude and direction. So if I give you the magnitude and I give you the direction of the vector, you should be able to write the vector. So not hard stuff today, a couple formulas, but just kind of knowing how to piece it together. So to start off here, we're going to talk about a unit vector. Just like a unit circle has a radius of 1, a unit vector is a vector with a magnitude of 1. Which means what? What in the world is a magnitude? The length. So the length of this vector is 1. Now yesterday when we found magnitude, it was the square root of 29, which is a little bit more than 5. We're going to talk about how to scale that back to make it go in the same direction, but to make its magnitude 1. Think about that. We have 2 standard unit vectors. I mentioned this yesterday, and they are the 2 things that we use to make up our vectors. They are I and J. Okay? Vector I is the vector 1I plus 0j. Basically what that unit vector is 1 unit on the x-axis. That's vector I. So I made a sketch of this. Vector I, the position vector, would start at 0, 0. It would go 1 unit to the right. That would be vector I. 1 unit on the x-axis. Yeah, it's an I without the dot. Vector I. This is vector J. I got my vector close to my J. So vector J is 0 i's, so there's no x component, no horizontal component, plus 1j. So what that is doing, its position vector is starting at 0, 0, and it's going 1 unit on the y-axis. That's vector J. Every vector that we write, we've been writing as components of I and J. Vector I, vector J. So it's always got a horizontal component and a vertical component unless they are 0. What is the magnitude of vector I? How long is it? It's 1 unit. Because if I took the square root of 1 squared plus 0 squared, it would be the square root of 1, which is 1. Okay? And also, if we have a vector that's horizontal or vertical, can we just count it? You have to use the formula for magnitude if it's horizontal or vertical? I don't think so. You can count horizontally number of units and vertically. You just can't count diagonally. Questions on those unit vectors? So the question becomes, how do we write a unit vector in the direction of a given vector? So I'm going to put my little vector symbols above here. So what we're going to do is we're going to take the vector that we've been given. In this case, it's called B. Typically, it's called B. And we're going to divide it by some weird notation. What is that notation again? The magnitude. So we're going to divide it by the magnitude of B. Now remember, if we take a vector and we divide it by its magnitude, what do we get when we find magnitude? Do you remember what we called that yesterday? A scalar. It's just a number. If we take a vector and we divide it by a number, we're just going to get a vector. Just like if we take a vector and we multiply it by a number. So if we have a vector that's 5 units long, isn't it true that if you divided it by 5, you would get a vector that's 1 unit long? That's what's happening here. Okay, unfortunately, you're going to have some radicals for your magnitude, so you're going to have to divide by some radicals. Well, remember, a vector is in terms of I and j. So you're going to take it, divide it by how long it is. It takes however long the vector is, and scales it down to be a vector that has a magnitude of 1. And you can actually find a new magnitude, and it would be 1. I'm going to go to that trouble. So here's our first example. So we're going to apply this. Find the unit vector in the same direction as this given vector. V equals 3i minus 4j. If I were to draw a picture of this, for those of you that are visual like myself, my position vector starts at 0, 0. I would go right 3, down 4. My vector horizontal walk looks something like that. Okay? Do you think that is 1 unit long? So what I am trying to do is figure out how long that vector is, and then divide it by something to where my final answer would be going in the same direction, but it would only be 1 unit long. So what do I have to find? The length. Very good. I have to find the magnitude. Length, magnitude, same thing. How do I find the magnitude of V? Yep. Square root of A squared plus B squared. So the square root of 9 plus 16. Yep, 25. So the square root of 25 is 5. So in this particular example, it's a nice integer. It will not always be nice integers. It will ask you to simplify it. So if it's radical 8, that's 2 radical 2. Okay. So what do I do with that magnitude? This blue vector is a length of 5. How do I make it a length of 1? Yeah, I take the vector 3i minus 4j and divide it by 5. What's 3 divided by 5? You get 3/5 vector I minus 4/5 vector j. 3/5 is 0.6, 4/5 is 0.8. Since those terminate, probably can leave it that way unless it says to make it a simplified fraction, which a lot of them are going to be fractions. You do not have to draw this. This was just for you to kind of see what was going on. Nope, you don't have to draw it. But basically, guys, what we've done is we've just cut this up into 5 pieces. 1, 2, 3, 4, 5. And so it would have to go 3.6 to the right, 0.8 down. That would be that length of that vector. That would be 1 unit long. Making sense kind of visually what's going on? Now, if we found the magnitude of this, what should we get? 1, right? So just so you can see this, how do we find magnitude? Well, the same way we just found it, correct? So if I take, you can just watch me here, but if I take the square root of 3/5 squared plus negative 4/5 squared, what should I get? I shouldn't be surprised that I'm getting 1. I now have a unit vector with length of 1. Good there? Questions on that? So how do we answer this question? What if we want vector B to have a magnitude of 8? So think about what B was, 3i minus 4j. It started out to have a length of 5. What if I wanted to have a length of 8, a magnitude of 8? What could we do? Okay, we multiply by 8/5. Okay, so what if some of you are like, where in the world is it getting that? What have we just found? We just found a unit vector, right? Isn't this unit vector in the same direction as B? But it has a magnitude of 1. So if I wanted to have a magnitude of 8, I could take my unit vector and times it by 8. Do you agree with that? Which is where we're hearing we can multiply the original by 8 divided by 5, multiply it by 8, but then divide it by its original length. Either way works. But we could just take 8 times the unit vector. Okay. okay, or original times 8/5. So what's 8 times 3? 24, so 24/5. I minus 8 times 4. Yep, 32. Again, if we took the original vector and multiplied it by 8/5, that would work. You're seeing that. Could I check the magnitude of this new vector? Could I find magnitude? And if I found it, what should it be? Better be 8 of the new one, of the final new one, right? That second one. Questions on that? Okay, then let's talk direction angle. A direction angle, which we're just going to call theta, is the angle that a vector makes with the positive x-axis. Remember that positive x-axis is important. Okay, and the reason that we're talking vectors after all we've done this semester is because vectors do kind of go along with the unit circle. You're going to see them mesh here in a moment. Okay, it goes along with trig. Right triangle trig at times, but definitely with the unit circle. When we were drawing things on the unit circle, remember that we always started an angle with the positive x-axis. That was standard position for any angle that we drew. Well, now we're talking position vectors, so they're going to start with the positive x-axis. Now, if we think about a vector, if we have to figure out what angle it makes with a positive x-axis, if it's in the first quadrant, if my vector ends up in the first quadrant, would you agree with me that's going to be acute? It's going to be less than 90. Do you agree with that? Okay. What happens if my vector ends up in the second quadrant? It's going to be between 90 and 180, isn't it? Okay. So do I have to have a vector that's only in quadrant 1 and 2? Could I have a vector in quadrant 3 and 4? I definitely could. It's going to be in quadrant 3, it's got to be between 180 and 270. And then if it's going to be in quadrant 4, it's got to be between 270 and 360 degrees. Now, can we have negative angles when it comes to a direction angle if it's made with a positive x-axis? That's going back to those angles we talked about. Go counterclockwise when they're positive and clockwise when they're negative. So they need to be positive because they're going along with the positive x-axis. Okay, so we're going to be looking at these positive angles. So if we get a negative angle, we have something that we're going to have to do. Okay, when you get an answer for this, it's not always going to be the answer. So this might be a place where drawing a picture can be helpful to you, or at least visualizing where the vector is. Okay, so if I have, let's just make it easy. Let's say I have a vector in quadrant 1. I don't know what it's called, but isn't it true that wherever it ends, the point would be AB? Do you agree with that? If this was 3A plus, or 3I plus 4J, this would be the point 3, 4. Agree there? Isn't it also true that we could draw in a right triangle from any vector? And we're looking for theta, which is what it makes with the positive x-axis. So we've talked about angles before. That's what we're looking for. We're looking for theta. How far is it between the origin and right there on the x-axis? How long would you say that is? A. How high is it? B. How could you find theta? What would you do? B over A would equal what? Tangent, right? Isn't SOHCAHTOA, this is a right triangle? Isn't this opposite over adjacent? I mean, you could use law of sines if you wanted to find that, but just opposite over adjacent is easier. So that's what our formula is for our direction angle. The tangent of theta equals B over A. Because when the angle that's made with the positive x-axis, that's the triangle we end up getting. It does become a little more complex than the other quadrants. Because if you think back a few months, whenever we did inverse trig functions, and we talked about inverse tangent, remember the quadrants our answers are going to come out in on our calculator? I'll tell you that one of them was 1. Remember what the other quadrant was? It was actually 4. Inverse tangent was quadrant 1 and 4. That's what your calculator is going to give you answers in. So giving you that, remember what your answers are going to look like in quadrant 4? It's been a while, I know, we don't use it a ton. They're going to be negative. Are we going to want a negative answer? Okay. My strong encouragement, it is an encouragement, not a requirement, is that you draw a picture before doing a direction angle. Because 9 times out of 10, unless you are very, very non-visual, you are going to miss it. Okay. So let's try one. Find the direction angle theta to the nearest tenth of a degree. And here's our vector. Vector B, negative 2i plus 3j. What quadrant is that in? Quadrant 2. So if it's in quadrant 2, what should my direction angle be between? What two numbers? In quadrant 2. 90 and 180. Here's 90, here's 180. So you better not give me an answer unless it's between 90 and 180. Otherwise it's wrong. Okay, so I encourage you to draw a picture. So I'm going to draw a quick sketch. It doesn't have to be beautiful. Position vector, we're going to go up 2. We're going to go up 3. We're going to see our vector. We are looking for theta. It actually doesn't make a right triangle unless you come to this other side. That's what we're looking for. So, to find theta, we do the tangent of theta equals 1 over what? B over A. What's B? 3 over negative 2. That's A, that's B. If you were making a right triangle out of this, guys, isn't it true that if I made a right triangle here, my board is off, so I apologize. This would be negative 2 and this would be positive 3, and I would only be able to find that angle? Is that the angle that I'm seeking? I'm seeking this angle, right? So you see some relationship between the two? I hope? Okay, so inverse tangent of 3 over negative 2. To the nearest tenth, what mode should our calculator be in? Better be in degrees. What button do we have to press to get rid of tangent? Inverse tangent. Inverse tangent of 3 over negative 2 is how much? So the nearest tenth, negative 56.3. Good. Is that the answer that we want? No, guys, that answer, what do we got for here? Negative 56.3 is that angle right there. That's negative 56.3 degrees. We know how to draw angles. How do I, in the world, if I get back to this? What's the relationship between the two? Yeah. Are they adding up to 180, the two of them? So can't I just add 180 to that? Because 180 minus that angle would have to give me the angle that I'm seeking. Is that making sense to us? So I'm going to add 180 degrees. That's where the picture can help. The two of those together better add up to 180. So I'm going to add 180 to that. I'm going to get 123.7. Is that between 90 and 180 like I expected? Yes. Okay, that's the angle we're looking for. Angle that's made with a positive x-axis. Let's try this one. Seen this vector already today. 3i minus 4j. I haven't set up your problem for that. I'm finding that position vector. 3i minus 4j. I'm again going to sketch a picture. Quadrant what? 4. So what should my angle be between it and the positive x-axis? I'm looking for theta, which is all the way around there. 270 and 360. My answer better be between 270 and 360, or it's wrong. And we haven't given the angle that we need. We're going to tangent of theta equals 1 over what? B over A. Good. Negative 4 over 3. B over A. The nearest tenth, what are you getting? Good. Negative 53.1. Is that my answer? Is that between 270 and 360? No. So think about what we just found. We just found the angle from the positive x-axis to my vector. Right? Do I just want to add 180? If I add 180, guys, it goes the opposite direction. That's what 180 does. Do I want it to be in quadrant 2? So what do I need to do? Add 360, because I want it to come all the way back to where I am. That's a co-terminal angle. Okay, that's where we're tying back into the unit circle. We're going to add 360, and we're going to get 307.9. Is that between 270 and 360? Obviously it is. So that answer is making more sense. Now, are you going to have to add 180 or 360 every single time? No. Here's the deal. If your vector is in quadrant 1, your answer is going to show up on your calculator. If your vector is in quadrant 2, you're going to get an answer in quadrant 4. So what are you going to have to add? 180. If your vector is in quadrant 3, you're not going to get an answer in quadrant 3. You're going to get an answer in quadrant 1. This tangent's positive in quadrant 1 and 3. So if your vector is in quadrant 3, you get 25 degrees for an answer. What are you going to add? You're actually just going to add 180. Yeah, you're going to add 180 and it's going to flip it the other way around. It might be 25 plus 180. If it's in quadrant 3, your answer will show up in quadrant 1. So if it's 25 degrees, you're going to add 180, you're going to get 205 degrees. Okay, and then if it's in quadrant 4, what are you going to add? That's going to be the time that you're going to add 360. Okay. If you want the vector that's in the opposite direction, add 180. If you want the vector that's just a positive instead of a negative in the same location, it's 360. Questions on that? I'll be here to help you as you're doing your homework. Okay, if you're working through it, you should be able to get there. Okay, last thing then is how do we write a vector in terms of magnitude and direction if that is the information that we are given. So we have two different formulas. They are basically the same formula. It's just one has the magnitude distributed, one does not. The vector symbols on there. Your online homework is going to want you to use the second one. That's the format. That's just the most common format. The first one is kind of how the setup looks. The second one is your polished answer. So you're going to be given the magnitude or the length. You're going to be given the direction. Those are the two things you're going to be given. Remember that the direction is the direction angle. You need to add that in. You need to be given the direction angle. So I'm going to tell you how long the vector needs to be and in what direction. Your job is to write the vector. Tell me how to get there. If I'm in a plane and I need to travel 150 miles and I need to go to a certain place, so I have an angle measurement, how am I setting my course? It's going to be ideal. Okay. Almost said it was copied down. So our last example, example 3, is going to ask us to write a vector. Write this vector in terms of the information that I've given. Okay, so here's the first one. Write the vector v in terms of vector I and vector j, whose magnitude and direction angle are given. So basically it wants us to write the vector. That's what it's asking us to do. Write the vector. So I give you a magnitude of 6, we should know that notation by now. And I give you that theta is 30 degrees. Ever seen a 30-degree angle anywhere? Or might we have seen a 30-degree angle before? We get a circle, right? Pi over 6, yeah. So we're going to be giving exact answers for this. So your homework is going to say it should be an exact answers. So we're going to write the vector. All we have to do, guys, is take the magnitude of the vector, which in this case is 6, and we have to multiply it by some trig function that pertains to the angle. Now, isn't it true that whatever comes with I is the unit vector on the x-axis? What trig function goes with x? Cosine. That's why that's cosine. So cosine of 30 degrees, and then vector I. The vector that goes along with j is the vertical component, that b value. That's on the y-axis. What trig function goes with y values? Sine. That's why the formula is the way that it is. So if you forget the formula, think back through what's going on. We need a horizontal component or an x component, and a vertical component or a y component. So, what is the cosine of 30 degrees? Pi over 6, we heard. What's the cosine of pi over 6? Radical 3 over 2. So the unit circle has not gone away yet. Plus, what's the sine of 30 degrees? 1/2. So all we have to do now is to distribute. What do you get when you take 6 times radical 3 and divide it by 2? Yep, 6 radical 3 over 2, 3 radical 3. We get 3 radical 3i. We should say vector v equals this. What's 6 times 1/2? Yep, so plus 3 vector j. There's my vector. Guys, if I were to graph this vector, what quadrant should it be in? It better be in quadrant 1 because it only has a 30-degree direction angle. That's quadrant 1. And if I were to find the magnitude of this vector, what should its magnitude be? Better be 6. You know how to find magnitude. If I were to find the direction angle of tangent of theta equals b over a, it better be 30 degrees. I can check all the work from what we've done today. Okay, you have a lot of checks. So here's our last one. Lost part of the magnitude piece there, but vector v, the magnitude of vector v is 1/2, and theta is 113 degrees. Do you know the exact values for 113 degree angle? Neither do I. So what do you think we're going to have to use? You do it in your head? So what tool do we have? Calculator. Okay, not a trick question, we're going to use calculator. Okay, so if we want to find vector v, what do we start with? Magnitude, good, 1/2. Then how do I use the angle? Cosine, good. Cosine of 113. And then vector I goes next to that. Plus what? Sine of 113, and then vector. Okay, think about this for a moment, guys. 113 degree angle. What quadrant are we in? We're in quadrant 2. That's 113 degrees. What do you know about your x value in quadrant 2? What about your y value? So So when we get this, shouldn't our first answer be negative and our second answer be positive? Otherwise something weird is up. So we have 1/2 times the cosine of 113 degrees I, and then 1/2 times the sine of 113 degrees J. Now you don't have to write that, but that's what we're doing. We're going to distribute this, and then we're just going to use our calculator to type it in. So again, we should still be in degree mode. We haven't been in radio mode all chapter. We're going to type this into our calculator. 1/2 times the cosine of 113 degrees. And what do we get? Go to the nearest 100. Should be negative, right? 0.195. So 2 nearest 100. 2 0. Okay, you see what you did? Okay. And then 1/2 times the sine of 113 gives us what? 0.46 J. Good. Guys, it's only a half. Think about this. This vector that I drew in is only a half of a unit. That's all it is. It's not going to be less than that very much. Okay, it's a half unit. Again, you can check the magnitude. Square root of a squared plus b squared better be pretty close to a half. We did some rounding, so it's not going to be exact. The tangent of theta would be 0.46 divided by negative 0.20. Better end up being right around 113 degrees when I find that. So we have a lot of checks here. Questions on that? Okay, so we know that your homework. You have part 1 that we went over yesterday. So I'd start there. Build that up, figure all that out, and then part 2. So part 1 is going to close Friday at 3, I believe. Part 2 closes Monday, like 7:30, I think. I could be mistaken on that. Don't think that I am.